Welcome to this WiseOwl tutorial. In this video, we're going to cover constants and enums, or enumerations, in Excel VBA. So the video is all about how you work with fixed values in VBA. We'll start with a quick explanation of what a constant is and how it compares to a basic variable. Then we'll mention some of the built-in constants that you can use, before we move on and show you how you can declare and use your own custom constants. Once we've covered that, we'll look at how to use enumerations, and again we'll show you some of the built-in enumerations first, before showing you how to declare your own custom enumerations. The final part of the video will look at how you can use enumerations in variables and parameters of other procedures, and we'll finish off by showing you how you can calculate the members or the constants stored in your enumeration. So there's a fair bit to do, let's get started. In VBA, a constant is simply a convenient label for a value which doesn't change. There are lots of examples of built-in constants in VBA, and you may well have already used them in your own code without realizing. So for example, if you've ever tried to change the color of a cell, you may have used a color constant to do that. So if I say ActiveCell.interior.color equals, and I wanted to make it blue, I could use the constant VBBlue to make that work. So there it is, there's the constant VBBlue. I can tell that it's a constant because of the little grey box symbol listed next to its name in the IntelliSense list. You can press Ctrl and space on the keyboard to display this, by the way. That also gives you an idea of how many other constants are available. Every time you see this symbol, that represents a constant. So here's another colour constant, VBBlack. I'm going to stick with VBBlue for now, and then I'm going to run this subroutine just to prove that it works. Not that it's anything particularly exciting, but just to show you that it works, and it changes the background colour of that cell to the value VBBlue. Although technically it doesn't change it to the value VBBlue, it changes it to the value that the label VBBlue represents. If you want to know what values your constants actually refer to, there are a couple of different ways you can see that. If I use the F8 key to step through this subroutine, you can let the mouse cursor linger over the name of a constant, and it will tell you in a little tooltip what value that constant represents. So in this case, it's a number, a long integer as it turns out, and in most cases, constants in VBA do represent numbers, although technically, a constant can represent any data type, so for instance string and date and so on. Another way to see the values of your constant is to use the object browser. So if I just reset my subroutine and increase the height of my screen again, we can use the object browser from the View menu, and we can use that to display a list of constants. So I've already scrolled to the one that I'm interested in here, VBBlue, but there's an enormous long list of various constants available, not all of them begin with the letters VB, of course. The best way to use this is looking at the globals category on the left-hand side, and then scrolling through the list to find all the constants on anything with this little grey symbol. If I go back to VBBlue, by scrolling down the list, I've typed in the letter V there to scroll quickly to this section. If you select the name of the constant you're interested in, you can see what its value is by looking at the bottom part of this window. So const VBBlue equals that number. So that's an idea of how basic constants work in VBA. What we'd like to move on to next is show you how you can design and declare your own constants and then use those in your own code. For the first example, we'll declare a couple of constants which hold some custom colours. So here we've got an example of the old WiseOwl logo with our lovely shades of blue and red. And what we're going to do is declare constants which hold references to those colours. So what I've done so far, just to demonstrate what these colours are, is to colour in cells using some specific RGB settings. So if I just show you quickly what these colours are, or at least for the blue one, I've used the red, green, blue colour model to specify the exact shade of blue. And also, for the red, use the RGB to specify the exact shade of red as well. What I'd like to do is create two constants which hold those colours, so I don't ever have to specify these exact numbers ever again. So, back into the VB editor, and I've created a quick little subroutine called declaring constants, and let's start by declaring the constant for our WiseOwl blue. Now declaring a constant is a lot like declaring a variable, except that instead of the word dim, you use the word const instead. So if I say const, and I'd like to call my first constant WO blue, so WO is short for WiseOwl, and then I have to say what data type it will be, and in this case it's going to be a long data type, so a long integer and a whole number. And if that was a variable, that would be all that you would do. You'd hit enter there, and you'd have declared your variable. But as you can see with a constant, that's not acceptable. When you declare a constant, you also have to assign a value to it at the same time. So after you've declared the data type, you have to say equals, and then say what value that constant will reference. Now the value that I want my constant to reference is the colour blue, or the YSL blue. And a convenient way to find out what that is to use the RGB function in VBA. I'm going to view the immediate window. And I'm going to ask the immediate window to tell me what the value for my YSL blue colour is using the RGB function. So I say question mark RGB, and the values for YSL blue will be 0, 152, 202. If I close the parentheses and then hit enter, that tells me that to generate that colour I need this specific number. So I can copy that from the immediate window, paste it in, and that's a declaration for YSL blue. I can do exactly the same thing then for YSL red. I can say const WO red as long equals, and I'll use the immediate window again to ask me to tell me what the red colour is, and that's going to be 205, 51, 1. If I hit enter at the end of that line, that's the numerical value for YSL red. So I can copy that, paste it into the code, and there's my two constants declared. Once you've declared some constants, you can immediately use them in code. So let's have a quick title in range C1 on this worksheet. Range C1.value equals YSOwl. And then we're going to change the background colour of range C1 to YSOwl blue. So I'll say range C1.interior.colour equals, then if I press Control and space and look for WO, I'll find WO blue sits in the list, and it has exactly the same symbol there as the built-in constants do. So WO blue for the background colour, and let's change the font colour to YSL red, because that'll look lovely, I'm sure. So .font.colour equals YSL red. And then, if I again just bring the window down so we can see what's going to happen in the background. Let me close the immediate window just for the moment so we can see this a bit more clearly. Then if I use the F8 key to step through, you'll see that again if you hover the mouse over the name of your custom constants, they will tell you what value those constants represent, just in the same way as built-in constants do. So there's the background colour, there's the font colour, and there's a very, very simple use for custom constants. Now, although it's possible to declare constants within a single subroutine, it's much more likely that in the real world you'll want to reference your constants either across all the subroutines in a single module, or even across all the subs in all the modules in your entire project. So if you want to extend the scope of your constants, you can declare them outside of the subroutines. So let's just quickly move our constants from within this subroutine up to the top of the module to begin with. So that extends the scope to the module level, which means that any subroutine in this entire module can refer to the values of these constants. If you want to extend the scope even further, you can change these constants from module level to project level, and you can do that by typing the word public in front of the word const, and that turns them into public constants, unsurprisingly. You may well have seen this in the variables video. You can do exactly the same thing using variables. I guess to represent a real-world situation, rather than declaring public constants at the top of a single module, you would ordinarily have an entirely new module in which all your public constants and public variables sit. So if I paste them in here and then call this module public constants, I suppose in the real world I call it public constants and variables, because that's ordinarily what you would put in there. But now any subroutine in any module in this entire project can reference our two constants. One very important thing to realise about constants, and the main thing which distinguishes a constant from a variable, is that once you've declared them, you can't reassign a value to a constant. It's kind of the whole point. The idea of a constant is that it is constant, it's fixed. So if I've declared YSL blue and set that it's this specific value, I can't change that in other code. If I head back to my constants in VBA module and I try to say WO blue equals, let's put in the number 1, 2, 3, 4, then although I can write the code that does that, as soon as I attempt to run it, I'll get a compile error saying that you're not allowed to assign a value to a constant. And that's absolutely completely sensible. That's exactly what constants are meant, or the way constants are meant to work. They're a fixed value that does not change. The only way I can modify what that constant references is by changing it at its original declaration. As well as using constants to set the values of simple properties, you can also use them in calculations. So to demonstrate that, we're going to create a couple of simple functions for calculating properties of a circle. So this is a bit of a flashback to high school mathematics. We're going to have a function called circle circumference, and this is going to calculate the circumference of a circle from its diameter. So we're going to ask the user to pass in the circle diameter as a double, and the function is also going to return a double. The calculation that we'll perform and return a value to the circle circumference function is to say circle circumference equals circle diameter multiplied by the value of pi. So I can remember that to about 3 decimal places, 3.141. So let's make it a bit more accurate. Let's cheat and use Google to get a much more accurate value of pi. And then we can paste that in. Then we'll also have a function called circle area. And this is going to calculate the area of the circle, unsurprisingly. We need to pass in the circle radius this time, and that's going to be a double, and the function is also going to return a double. We can say then that the circle area is equal to the value of pi multiplied by circle radius squared. So circle radius multiplied by circle radius is one simple way to do that. Okay, so there's the two functions, both referencing the same value, the same constant value. That doesn't change between the two subroutines, and it's unlikely to change in any other calculation in which we use the value of pi. So rather than using the hard-coded number, which is awkward to type in the first place, a constant would be a much better way to do that. Now this time the constant definitely needs to be referenced in more than one procedure. So let's declare our constant at the top of the module. I'm going to call this const pi as, and the data type this time will be double, so not just a long integer as in many other cases, and then I can paste in that same value again to assign a value to the constant in its declaration. All I need to do then is replace any reference to that number with a reference to the value or the constant pi, and there it sits in the list again with that same little grey box symbol. I can do that here again, remove the number and replace it with a reference to pi. I suppose we should give our functions a quick test, shouldn't we? So let's have a quick subroutine called circle properties, and we'll ask the user what the circle's radius is and store that in a variable. So I'm going to say dim circ rad as a double. We'll have another variable there called dim circ diam also as a double. And then we'll ask the user what the circle radius is by saying circ rad equals input box, or what's the radius? We can then calculate the circ diam by saying circ diam equals circ rad times 2, nice and simple. And then we'll have a message box which displays the circumference of the circle, and another one which displays the area. So let's say message box, and we'll say the circumference is, and then we'll concatenate that together with the result of the circle circumference function. So circle circumference, open parentheses, and there we'll pass in the value of the circ diam variable. Another message box then, message box, the area is, and here we'll concatenate the result of our circle area function. So circle area, and we'll pass in the circ rad parameter, or value of the circ rad variable. Okay, let's step through this one using the F8 key. So we can see that we'll ask the user what the radius is. I'm going to put in, I know 7, for example. Hit OK, and then that will be multiplied by 2 to get the diameter, and then we'll call on our circle circumference function. And this is going to reference the pi constant, and again if I hover the mouse over the value pi, it tells me what value is stored in it, and this will calculate a value for the circumference and return that to a message box, and there's the circumference of the circle. And then, if we show the next message box, that will call on our circle area function, again referencing the value pi, or the constant pi. So that calculates the area and returns that to another message box. So, simple example of using constants in calculated values rather than just setting the values of simple properties. Earlier in the video, we declared a couple of simple constants to hold the values of colours. We had yzl blue and yzl red. But what if we had a larger family of colours that we wanted to be able to reference, and we wanted to group them together in some kind of sensible, logical way? Well, that's where enumerations come in. Now, just like with constants, there are a bunch of built-in enumerations in VBA. If I head into my new module here, Enumerations, I'm going to try to change the colour of a cell. Again, I'm going to say active cell dot interior dot colour equals. Now, earlier I looked at the idea of the VB colours, VB blue, VB black, etc. And there's only 8 of those. Since XL 2007, there's been a whole other family of named colour constants called the RGB colours. So if I press Ctrl and space and said RGB, we saw that function used earlier on, but you can also see there's a list of constants here with some wonderful flowery named colours that we could use. Now, all of these RGB colours are actually part of a family, an enumeration called XLRGB colour. You can see it in the IntelliSense list here. Whenever you see this little symbol comprising of 2 small yellow boxes, that represents an enumeration. And all an enumeration is a collection of constants. So if I say XLRGB colour dot, that then subsequently shows me a list of all the constants which belong to that enumeration. So another way to display blue would be to say XLRGB colour dot RGB blue. The XLRGB colour part is optional. I don't need to provide that. RGB blue being a constant, it's acceptable to put that in without the qualification of the enumeration. You can see the enumerations in the Object Browser just as you can with the values of the constants. So if I head to the View menu again and choose Object Browser, if I looked for RGB blue in the IntelliSense list, you'll see that that's just another constant, and it actually has exactly the same value as VB blue. If I wanted to see what the full list of RGB constants was, then I can click on, you see here where it says member of XLRGB colour. If I click on XLRGB colour there, that takes me to that definition, the definition of that enumeration in the list. If I select it, it says Enum XLRGB colour, and then it shows me on the right hand side all of the constants which belong to that enumeration. And again, here you can see, you get an idea of how many different enumerations there are available in Excel VBA. So what we'd like to do is declare our own enumeration, which holds a custom set of colour constants. Now, although you can declare single constants within the scope of a subroutine, if you want to declare an enumeration, that must be done at the module level. So what I'm going to do is head back to my public constants module, and I'm going to declare a new enumeration in here. I want to make it public so that it can be referenced in any module in this project. So I'm going to say public enum, and then think of a name for my enumeration. I'm going to call mine WO colour. Well, in fact, I can spell it the proper way, can't I, as well? I can call it WO colour, spelled properly. Sorry, Americans. And then give yourself a couple of blank lines and say end enum. And then within the top and the bottom, between the top and the bottom there, we can declare all of the constants which will be part of that enumeration. So I'm going to start actually by declaring WO blue, and then WO red, and then WO, let's say orange as well, and WO brown, and we could carry on and on and on. We could have as many different constants within this enumeration as we like. Now I'm going to comment out the 2 public constants at this point, because we're going to redefine YSL blue and YSL red within the enumeration. And at this point, these constants do have a default value. Enumerations are based from 0, so if I wanted to have a quick look at what these constants currently reference, I can view the Object Browser again. Easiest thing to do here is limit the list so that you're only looking at things defined in the VBA project, and that will show you any enumerations you've declared with the same little 2 yellow box symbol, and if you select that, it shows you a list of all the constants declared within them. So I put blue first. You can see that blue has a value of 0, red has a value of 1, orange has a value of 2, and therefore brown must have a value of 3. That's not particularly useful, because we know that our custom YSL colours have very specific values. So, within the enumeration itself, all you need to do is say what value those colours, or those constants, should represent. So it's quite simple, just declaring a whole family of constants in one single place. Now I haven't calculated what the orange and the brown colours are yet, so I'm going to display the immediate window, and then use my good old RGB function to find out what these are. So the YSL orange will be 240, 132, 30. Oops, I forgot to put my close parentheses in there. And then I can copy that number out and say YSL orange equals that number. And then for brown, the numbers for brown will be 99, 42, 39. And then that gives me this number, which I can copy out again, and then assign that number to that constant. So if I have a quick look in the object browser again now, I can view the object browser, and it should show me now that the values for these colours have now been reset to the ones that I've specified. Before we use this enumeration, it's worthwhile quickly mentioning one small restriction that you have. Earlier on we saw that with constants you can use essentially any data type, so we used double for pi. We could also have used string and dates and so on. With an enumeration, however, you're restricted to using the long data type. So effectively you're restricted to a number between 0 and about 2.147 billion, but you can only use whole numbers for the constants in enumeration. So now that we've declared the enumeration, we can use that in normal code. So let's head back to the enumerations module. I'm going to have a quick extra new subroutine called use enum. And let's use range D1 this time. So I'm going to say range D1 and dot value equals YSL again. And then I'm going to use the enumeration to set its foreground and background colours. So I'm going to say range D1 dot interior dot colour equals, and if I wanted to, I can reference any of the constants in the enumeration directly. So I could say, for instance, YSL orange or WO orange, and that would reference that constant directly. But sometimes it's nicer to use the name of the enumeration first. So if I say WO colour dot, and then I can pick from a limited list of the constants that belong just to that enumeration. So I can say WO colour dot WO orange, and again for the font colour I can say range D1 dot font dot colour equals WO colour dot WO brown. So now that I've done that, let's have a quick look at stepping through the routine again. If I use the F8 key to begin stepping through, again I can hover the mouse over any constant name in enumeration and it tells me what the underlying value is, and unsurprisingly all those things will be changed in the same way. Looks a bit horrible actually, but anyway, never mind. That's the idea of using an enumeration. It's simply a group of constants. Now, one of the really cool things about enumerations is that once you've declared them, you can also use them as effectively a data type for other variables. So let's say I want to change the way this subroutine works slightly. Rather than explicitly stating which colour I'll use for the interior and fonts, what I'm going to do is store those values in other variables. So I'm going to have dim primary colour as YSL colour. You'll see that the enumeration appears in the IntelliSense list. And I'm also going to have dim secondary colour as another YSL colour. What I can then do is store which colour I want to use in those variables. So I can say primary colour equals, and the brilliant thing is, as soon as I type in the equal sign, I get the IntelliSense list showing me only the acceptable values from that enumeration. So it's essentially a validated data type almost. So this time I'm going to set the primary colour to YSL blue, and I'm going to set the secondary colour to be equal to YSL orange, let's say. What I can then do is, instead of referencing explicitly these values, I'm going to say that the interior colour of the cell is equal to whatever the primary colour is, and the font colour of the cell will be equal to whatever the secondary colour is. Let's look for secondary colour in that list. So there we are. If I run that subroutine again now, we should see, if I step through it using the F8 key, that we'll see the primary colour goes to YSL blue and the secondary colour YSL orange. So there we go. The beauty of using this sort of system is that, let's imagine you were doing lots and lots of colour changes to lots and lots of individual cells, and you wanted to use a particular theme for your colours. You might have a whole range of primary, secondary, tertiary colours. If you decided that you wanted to change that theme, and you'd referenced each colour constant independently, every single time you change the colour, you'd have to modify lots and lots of different lines of code if you ever wanted to change it. when you store those values in variables, of course, there's only one single place you need to change the primary, secondary and tertiary colours, and then that will affect the rest of the subroutine. The IntelliSense feature also works well with enumerations when you're passing them as arguments to different procedures. So what we'll do here is we'll create a couple of calculations to work out how much people get paid, and we'll do it using an enumeration which works out how many hours there are in each period of time, so how many working hours there are. So I'm going to start with a public enumeration called WO work hours. And in there, we're going to have a few values. We're going to start with the WO day. So the working day for YSL is going to be 8, as in 8 hours. Then we'll have WO week, which is the same as 5 times 8, so 5-day working week, which is equal to 40. And then we'll have a WO month, which is a little bit more rough and ready, but let's assume it's a 20-day working month, so we'll say that the number of hours is going to be 160. Okay, so there's the enumeration declared. Now we'll create a function which uses that enumeration as one of its parameters. So let's have a function called YSLPay. And in there we'll pass in two different parameters. We'll have the hourly rate, so we'll just let the user put that in as they see fit, hourly rate as currency. And then the second parameter will be unit of time. And for that we're going to use our enumeration WO work hours. We're going to say that the function returns as currency, and then in there we can perform a very simple calculation. Let me just drag the screen across so we can see that a bit more clearly. What we'll do is we'll return YSLPay is equal to hourly rate multiplied by unit of time, so whichever value gets passed in via that parameter. Now what we need to do is call that function and pass in a couple of values to make it calculate the result. To do that, we'll create a new subroutine called calculate my pay. It's fairly obvious what this is going to do. And in there we'll have a variable called dim pay per hour as currency. And then we're going to ask the user what their pay per hour is using an input box. So we'll say pay per hour equals input box, and then say what's your hourly rate. What we can then do is work out three different values. We can work out the pay per day, pay per week and pay per month by calling our YSLPay function 3 separate times. So let's have a message box which displays your daily pay is, and call our YSLPay function. So we'll say YSLPay, and the first parameter that we're going to pass in, or the first argument we're going to pass into the hourly rate parameter, is going to be pay per hour, whichever the user types in. And then when we type a comma, here's the great bit, you once again see the IntelliSense list. So we're going to use the WO day value for the YSL day constant, and then we can do the same thing again. I'm going to copy and paste that line a couple of times, and then say weekly pay rather than hourly pay, and then monthly pay, which should be a bit more rough and ready, and then we can simply modify these units. So rather than using YSL day for that one, we'll type in a comma and use YSL week instead. And then rather than using YSL day there, retype the comma and select YSL month. Okay, so now that we've done that, let's run this one through. Let's step through it using the F8 key actually. So we start stepping through using F8, hourly rate of, I don't know, £8.50, so 8.5. Click OK, and we'll call our function using the unit of time, which will be 8 because we're passing in a YSL day. So there's the unit of time is 8. £68 per day. Week, that will be 40 because that's what the YSL week constant references. And finally, YSL month, 160, and that gives us another answer for that. So there's the beauty of using enumerations for variables and as parameters for other procedures. Now, one small problem with our enumeration as it stands is that if we ever need to change the number of hours in a working day, then we've also got to update the week and the month. Now, that should be fairly unlikely to happen. Again, the idea of using a constant over an enumeration in the first place is that you're storing values that don't traditionally change. But there is the potential for, in this particular example at least, for these values to be modified. So let's say, for example, I wanted to change the day to a 7-hour working day. That means the week's got to go to 35 and the month has got to go to 140, which is a little bit tedious. So instead of actually typing in the exact numbers, once you've declared one constant in an enumeration, you can then refer to that constant again for later values. So I can say WO week equals, rather than the number 35, I can make it equal to WO day multiplied by 5. And likewise for month, I can say WO day multiplied by 20, or indeed WO week multiplied by 4. It would be the same thing. So once I've done that, let's step through this calculate my pay subroutine again using the FA key. I'm going to put in the same hourly rate, which is 8.5, and then I'm going to call my WO day, my YSL pay function this time, passing in the YSL day constant, which you can see already is the number 7. So that calculates a unit of time using the value 7. And then for the second one, YSL week, you can see it's already calculated that the YSL week is 35. So it's 7 multiplied by 5. So we'll get the result for that, and likewise for month, that's days 7 multiplied by 20, which is 140, and so unsurprisingly, you get the correct answer once again. If you're going to use this technique to calculate the values of constants in an enumeration, it's important to realise that the values you reference here must be other constants. So for example, WO day doesn't actually have to be part of this enumeration for it to work. What I could do is say public const WO day equals 7, and then comment this out from the enumeration, so it's declared separately, and then this subroutine will work in exactly the same way. If I run it just using the F5 key and type in a value, I'll get exactly the same answers again. What I can't do, however, is make this a variable, so it must be a constant. I can't say public WO day as long, and then in my subroutine itself I couldn't say, for example, WO day equals 7. If I try to run this one now, it will fail immediately with a compile error, saying that I must use a constant if I'm creating a basic expression in my enumeration declarations. So, just to be aware of the fact that it must be a constant that you're declaring there. So I can remove this, uncomment WO day, and remove that line as well, and everything will work again. If you've enjoyed this training video, you can find many more online training resources at www.ysl.co.uk.